Welcome everybody to our semester 1 final review video. I'm going to go through each of these review problems and I'm going to answer them correctly, give you a little guide for how to do them correctly. Now, what I would love for you to do is to keep up with me, pause it if you need to, but try to solve the problems before I do. So pause it, be like, oh, we're problem number 2, I'm going to do it myself, then you do it. So let's go ahead and work on problem number 1. Try and solve it now. I'm going to go ahead and solve it, and it will solve them pretty quickly, so definitely pause. Take a look at this. This is a length of 29. We know that because it says Fn is 29, and it's comprised of 2 smaller segments. From the segment addition, we know that those 2 segments will add together to be 29, and we can use that to solve for the value of r. 4r minus 3 plus 7r plus 7 is equal to 29. Going ahead and combining like terms, I end up with 5r plus 4 is equal to 29. Solve for r, you subtract 4 from both sides, then divide by 5. r is equal to 5. So that's great, we solved for r, but we can also plug it in. Remember, in geometry, almost always we want to plug it in. So this side says r plus 7, so that's really 5 plus 7, which is going to be 12. Now I can find the other length by plugging in r. 4 times 5 is 20 minus 3 is 17. I could also find it by just taking 29 and subtracting 12. That gives us 17. So I now know the lengths of all 3 line segments. All right, second one. We have a set of parallel lines, so we're going to draw the parallel line symbol to show that they are parallel. And because we have parallel lines, we have a whole bunch of angle relationships. So let's go through some of those angle relationships now. Okay? So first of all, we've got some alternate interior angles. And alternate interior angles are on the interior, and they alternate. So 5 and 4, 2 and 7 are alternate interior angles, but they're also congruent. So angle 5 is congruent to angle 4. Angle 2 is congruent to angle 7. Those are pairs of alternate interior angles. Corresponding, there's 4 sets here, and they're in the same position. Angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Same side interior. Those are ones on the inside, and they're on the same side of the transversal. By the way, line P is our transversal. So which ones are on the same side? 2 and 5, 4 and 7. So those are same side interior angles, and they are not congruent. They are supplementary. So we'd say angle 2 and angle 5 are sup. Okay, and we also have 4 and 7. Angle 4 and angle 7 are supplementary. Sup. Okay, same side exterior have the same conclusion, but they're on the exterior. So angle 1 and angle 6, comma, angle 3 and angle 8 are supplementary. Okay, alternate exterior angles, that's like 3 and 6, and they're going to be congruent. Angle 3 is congruent to angle 6. Angle 1 is congruent to angle 8, alternate exterior angles. Vertical angles, there's 4 pairs of vertical angles, and they're congruent as well. Angle 1, sorry, that should have been a 1. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Angle 5 is congruent to angle 8. Angle 7 is congruent to angle 6. Okay, lots of vertical angles that are congruent. All right, points X, Y, and Z are collinear here on problem number 3. That means they lie on the same line, which also means we've got a 180-degree angle. That means that this and this are a linear pair. So I'm going to label those LP for linear pair. All right, since they're a linear pair, they add to 180. Let's go ahead and solve that equation. 10a plus 2 plus 5a minus 2 is equal to 180 degrees. or I'm going to put 180 and we'll add degrees at the end. All right, so in looking at this, I know that 15a is equal to 180. Divide both sides by 15, I end up with a is equal to 12. But again, we want to plug it in, plug it in. So 10 times a, that's 10 times 12, is going to be 120 plus the 2. That gives us a total angle of 122 degrees. 5a minus 2. I just plug in the 12, that's 60 minus 2, and that's 58 degrees. All right, next one. We want the slopes of the new roads. So if we come over here to Austin Avenue, it goes like this. So we want to find out its slope because this road will be parallel to Austin Avenue. So let's go ahead and find the slope of Austin Avenue. And if I go this way and this way, you can see it goes over 1 and up 2. So my slope is 2 over 1. 2 over 1. So that's the slope of Austin. The parallel line is going to be the same because parallel lines have the same slope. Equal slopes. Now, slopes are numbers, so we can say that they're equal, but if they're shapes, we would say that they're congruent. So what about a perpendicular road to Austin Avenue? Well, as Austin Avenue is going up, our perpendicular line is going to go down. And as its slope is 2 over 1, our perpendicular line is going to go down 1 and over 2. Notice how they follow that same pattern. It turns out that perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes are slopes that are positive versus negative, and reciprocal means that they are flipped. So if the slope of my original line is equal to 2 over 1, then the slope of my perpendicular line is going to be negative, that's the opposite part, and then flip the fraction, 1 over 2, negative 1/2. So the slope of my perpendicular line will be negative 1/2. All right. So what about the slope of the equation of a line that's perpendicular to the line y equals negative 3x plus 2 and passes through the point 6, 8? So the first thing we need to do is know that it's perpendicular. So the slope of our original line is negative 3, or negative 3 over 1. So the slope of our perpendicular line is going to be 1/3. Again, flipped fraction and that opposite. So 1 was negative, the new one's positive. All right, we also know we've got a point there, and our point is 6, 8. So we can write this equation in point slope form very, very easily. We would just write it like this. Y is equal to 1/3 times x minus 6 plus 8. This is our point slope form. You use the point and bring it down. Remember, the x-coordinate's always opposite, and we just bring down the slope. Point slope form. All right, what's the value of x in this equation? We've got 2x plus 15, x, and 2x. Well, just looking at it, what if we know that all three angles add up to 180 degrees in a triangle? This is the triangle sum theorem, and I'm not going to write it right there. I'll write it right outside. Triangle sum theorem. So x plus 2x plus 2x plus 15 is equal to 180 degrees. X plus 2x plus 2x is 5x plus 15 is equal to 180. So subtract 15 from both sides, and I end up with 5x is equal to 165. Divide both sides by 5, and I end up with x is equal to, I can't remember what 165 divided by 5 is. That would be 33. There we go. All right, number 14. What rigid motion maps the preimage to the image? Well, our first one, preimage to the image, pretty simple line. This is a reflection line. So I'm going to draw it right there. It's reflected across line L. So I'm going to say that. Reflect across line L. All right, this one looks like it was definitely either flipped twice or it was rotated, and it turns out that a rotation is a pretty easy one to describe. Just put the center at where that center of rotation would be, and this point was rotated to this point, which looks like it's approximately 180 degrees. So I'm going to say rotate 180 degrees about, and I got to give a name for that point. I'm going to say point G. All right. Next problem. Quadrilateral ABC is rotated 90 degrees clockwise. Is each statement true? AB is congruent to A prime, B prime, or their distances are the same. Yes. If AC is congruent to BD, then A prime, B prime, or A prime, C prime is congruent or is parallel to B prime, D prime. Yes. And the measure of angle ABC is bigger than the measure of A prime, B prime, C prime. No. And then all of these stem from the idea that a rigid transformation, that's a rotation, reflection, or translation, change this direction or the orientation of an object. They do not change the object's size or shape. So the angles don't get bigger or smaller, the sides don't get bigger or smaller, and it preserves those directions. So parallel will stay parallel. All right. This one I did with my class and I forgot to erase it, so just give me a second real quick so I can erase these. All right, delete, not duplicate. I'm gonna go ahead and delete these. Boom, boom. Come on, cut. There we go. All right, so let's say we take this point 2, -7 and translate it according to this rule, -3, 1. That means we're gonna move left 3 and up 1. Okay, so I'm going to apply this to the input, and my input is 2, -7. So if I move the 2, 3 to the left, then it's going to become -1. And if I move the -7 up 1, it's going to become -6. And I can see that with just some simple addition and subtraction. 2 minus 3 is -1. 1 minus 7 is -6, or -7 plus 1 is -6. All right, what about this one? Well, we got to make a quick change here. We got to do a rotation, not a reflection, not a capital R. We're going to do a lowercase r. So we're going to rotate this 180 degrees. Now, it doesn't say this, but whenever we don't have one of these, the automatic assumption is this is a rotation about the origin, and our origin is 00, or 0.00. All right, so we're going to rotate this 180 degrees about the origin. Well, what would that result in? It turns out that if we take our input 2, -7 and we rotate it 180 degrees about the origin, then all that's going to happen is our points are going to switch places. So I'm going to go ahead and kind of show you that here. We're going to start our point down here, 2, -7, and if I go 180 degrees, it's going to go up here. Notice how that 2, -7, the -2 is still about the same distance away from the x-axis, so it's going to be -2, and the y-coordinate is the same distance away from the y-axis, so it's -2, 7. All right, what about if we reflect across the y-axis? Then, if we do this to the to our coordinates, 2, -7, this goes on a grid, and we can, again, kind of see it a little bit easier on a grid. So if you're having trouble, make a grid on your scratch paper, 2, -7, and if it reflects across the y-axis, which is that vertical line, it'll end up right there. So that'll produce -2, -7. It doesn't get higher or lower, but the x-coordinate switches places. Notice that the x-coordinate becomes the opposite. Okay, what if we do 2 transformations at once? We do a translation, then a reflection. Well, let's find out. Okay, so first we're going to apply this to the input of 2, -7, and let's go ahead and make a quick graph of what that looks like. So we're going to start here. Now we're going to translate it, -3 up 1. So -3 brings it right about here. -3 and up 1. It's a little too far up, so I'm going to make one quick change. -3 and -6. We actually did this already with those, or -1, -6. All right, now we need to reflect across the x-axis, and remember the x-axis is right here. So we're going to reflect across this green line, And whenever we do, we end up with a point that's right over here. Now that point is going to keep the same x value that we got after the translation, -1, but the y value becomes positive. So it'll be -1, 6. All right, next one. Which triangle is congruent to triangle PQR? So let's go ahead and look at PQR. Notice that it goes up 1 over 3, or up 2 over 3, down 1 over 2, and over 1 up 3. So we want one that has the same process there, and it definitely looks like this one. Sides congruent, sides congruent, sides congruent. So these two are congruent, and if you want to use a shortcut, it's side, side, side. We can also use a reflection rule. So if we use PQR and reflect it across the y-axis, it goes from, let's just pick point R, it goes from +4, +3, to +4, -3. So reflected across that x-axis, R gets there. P goes from 2 on the x, stays 2 on the x to get to D, and 4 to -4. So it's definitely looking like a reflection. So we can actually write that out and make a reflection rule. We can reflect across the x-axis the coordinate, or the shape, triangle PQR. Okay, we're going to reflect that across the x-axis, and it creates triangle DEF. Now I wanted to make sure I kept that order. P and D match up. Q and E match up, and then F and R also match up. All right, what is the measure of angle RST? This is another one that I did not erase, so let's quickly kind of go through it. In this one, you want to recognize what types of special triangles they are. In the case of the triangle, both triangles, they're isosceles triangles, ISO. So since they're isosceles, the two sides are congruent. As we can see, that's how we know they're isosceles, but also the two base angles are congruent. So these are congruent in that triangle, and these are congruent in that triangle. So let's go ahead and draw those symbols. This is congruent to this. Now, how do we find out what that is? Well, we can use the triangle sum theorem, TST. 180 degrees minus 64 degrees is equal to 116 degrees. And then, in order to get that, we want to take 116 and divide by 2, and that's 58 degrees. So 58 degrees here, 58 degrees here. Ooh, what about this angle? Well, it turns out that this angle and this angle are congruent because they're vertical. So I'm going to write that down. These are vertical angles. Okay, so this one is also 58 degrees. Now, if I take 180 and I subtract 58 degrees, I get 122. Now, 122 cut in half is going to be 61. So that means these two angles, which are congruent, are each going to be 61 degrees. All right, next problem. What value of x would support the conclusion that triangle JKL is congruent to triangle JML? So let's take a look. JKL and JML. Okay, are those congruent by angle, angle, side? Well, we know that they're congruent with one thing. They both have a congruent side, so I'm going to mark that. And then they also have two parallel lines cut by this transversal. So that means we've got alternate interior angles that are congruent. So far we have an angle and a side. In order to work through this, we need this angle to work because that would give us angle, angle, side. So this needs to be congruent to that. In order for them to be congruent, we can write an equation. So, and I can say it like this. 2x plus 18 is equal to 3x minus 47. Okay, subtract the 2x from both sides and add the 47 to both sides. And we end up with minus 2x, minus 2x, minus 47. Okay, get rid of those, and we end up with x is equal to 18 plus 47, which is 65 degrees. Okay, so what does x have to be? X has to be 65 degrees. And since we can find the measure of these angles, we might as well do it. If x is 65 degrees, 2x is going to be 130 plus 18, which is 148 degrees. All right. That means that's 148, and this is 148 degrees as well. All right, next. By which theorem can you conclude that these two triangles are congruent? Let's take a look. Ooh, this is a right triangle, so we can use the right triangle theorems. We got a side that's congruent. This is the leg of a right triangle, and the hypotenuse of our right triangle is congruent. It's opposite the right angle. So this triangle is a right angle with a hypotenuse and a leg. This one looks like it could be, but we don't know if it's a right triangle yet, except we do, because these are vertical angles. Vertical angles are going to be congruent. So we know that DHF is congruent to EHG by hypotenuse leg using vertical angles. All right. Which theorem of triangle congruence shows that triangle TUV is congruent to triangle WVU? So let's see, TUV and WVU. No. Okay, so let's take a look. TUV is right here, and WVU is right here. How can we say that those two triangles are congruent? Well, if we take a look, T to V has a side. These three sides are the same as these three sides. So that's one side that kind of matches. So we have side here, and then we've got a side here as well. Take a look at UV. They both share that. So this is a side as well. So far we've got two sides. Now if you think about our different shortcuts, there's side, where we would need to show that this side is congruent to this side. We don't know anything about those sides, so that won't work. What about side, angle, side? So if I show that this side is, or that this angle is congruent to this angle, those are in between my two congruent sides. That'd be side, angle, side. Hey, wait a second. Let's take a look at this. That's an isosceles triangle. Okay, I'm going to write that down. This is an iso triangle. Okay, since it's an isosceles triangle, that means that this and this are congruent. So these two triangles are congruent by side, angle, side using isosceles triangles. The properties of an isosceles triangle allow us to say that they're congruent. All right, for questions 10 and 11, use triangle DEF. What is the length of DF? So let's take a look. DF is right here. Well, we know that this is an angle bisector, and this is a isosceles triangle. So if it's an angle bisector and we've got an isosceles triangle here, we know that this length is congruent to this length, and we know that this angle bisector here has a congruent angle there. And they have a congruent side. So these two triangles, and I'm going to write this down, triangle GFE is congruent to triangle GDE. Those two triangles are congruent by side, angle, side, or SAS. Since the triangles are congruent, that means, so 3A is equal to A plus 6. Solve for A here and subtract it from both sides. 2A equals 6, A equals 3, which tells us the length of FG and GD. If we plug in A for 3 here, that's 3 times 3, which is 9. So the length of this is 9. And since it's congruent, this length also has to be 9. Oh, and we know that those are congruent. All right, and we knew that they were congruent because we had congruent triangles. With that said, we now know the length of DF. DF is equal to FG plus GD, which is equal to 9 plus 9, which is 18. Awesome. Which of the following describes the length of EG? Is it a median, an angle bisector, an altitude, or a perpendicular bisector? And it turns out that it is an angle bisector because it cuts this angle in half. But that doesn't make it not anything else. It also turns out to be a median. Now, we only spent a few minutes on median, but a median is the same. It goes from a vertex to the opposite side, the midpoint of the opposite side. So it is also a median. Is it a perpendicular bisector? Well, we know that it's bisecting because those are cut in half, but we don't know if it's perpendicular. So let's just double check and see. Looking at this angle, that's a straight angle, and these two need to be congruent. So that tells us that we have two right angles here because they need to be congruent. Two right angles makes perpendicular, which means it is a perpendicular bisector. So we can go ahead and highlight that one too. Is it an altitude though? An altitude is perpendicular to one side and it goes to the opposite vertex. Perpendicular goes to the opposite vertex. So EG is an altitude. So it's actually all four. All right, turn the page. And list the sides of XYZ from shortest to longest. So we know that this length is 63. We know that this is 58, which makes our third side 59 degrees using the triangle sum theorem. So which side's longest? Which side's shortest? Which side's next shortest? Well, it turns out that X is the shortest side because the angle's the smallest. Next, oh, and this is side X right there. Next, side Y is the next longest because it's 59. And then finally, side Z is the longest because it's paired with the 63 degrees. This goes from our angles and side relationships in triangles. What is the range of possible values for X? Now, we did this as a test question or similar one to it as a test question. Notice that this length is the same as this one, and then they share this length. So this is like a door opening on its hinges. Which doors open more? The 36. So since it's open more, this has to be greater than 3x minus 6. So that's what I'm going to write down here. 24 degrees is greater than 3x minus 6 degrees. Okay? So since I know that that's greater, I can go ahead and solve, but there's also one more thing. Because this length is positive, I know that this angle has to be greater than 0. So I'm going to add one more rule to it, greater than 0. Now let me go ahead and solve for x. In order to solve for x, I have to undo things. So I can add 6 to all parts. Add 6. It's like both sides. You just treat this as a set of both sides, and then this as a set of both sides. Okay? So we're going to add 6 to each part of them, and that gives us 30 is greater than 3x, which is greater than 6. Okay? Divide each one by 3, and we get our range of x values. Okay? Divide each one by 3, and we end up with 10 is greater than x, which is greater than 2. So we know that 2 is less than x, which is less than 10. We know that it's going to be between there. Is each statement true for triangle ABC? Well, let's take a look at triangle ABC before we decide if things are true. Isosceles triangle, so base angles are congruent, which means since this is a right angle, this is also a right angle. These two triangles are congruent by angle, angle, side. Angle, angle, side. Again, isosceles makes those congruent. Right angle makes that congruent. So these two triangles are congruent by angle, angle, side. So these are also congruent, which means we can go ahead and solve for x. Let's do that before we answer any questions. 4x minus 8 is equal to 3x plus 7. Solve for x. Add 8 to both sides. Subtract x. X is equal to 15. So we know that x is equal to 15. Let's go ahead and find the length. If we find either of them, we've got them both. So 15 right there. 15 times 4 is 60 minus 8. That's going to give us 52 degrees. That means this is 52 degrees. Awesome. So let's go ahead and take a look. Because these are congruent, we also know that those lengths are the same. So does CQ bisect angle ACB? And the answer is yes. CQ is the perpendicular bisector of AB. Yes, it's perpendicular and it cuts it in half. And the measure of QCB is equal to 26 degrees. Let me just take a look and double check on that. Nope, it does not equal 26 degrees. It equals double that, 52 degrees. All right, with that taken care of, let's go to 21. A triangle has two sides whose lengths are 31 centimeters and 39 centimeters. Which best describes the length of the third sides? Now this goes into, if it's too long, you can't make a triangle. If it's too short, you can't make a triangle. So we know that 39 minus 31 is equal to 8. So we know that our triangle has to be bigger than 8, or else it would just make a line segment. 39 plus 31 is equal to 70. So we know that x, or the third side, I'm just going to write third side. We could describe third side as something else, but our third side has to be greater than, oh, wrong symbol, has to be greater than 8, and it has to be less than 70 for us to make a triangle. All right, is point M the end center or the circumcenter? Let's take a look. Point M, we've got an angle that's cut in half here, and an angle that's cut in half here. Looks like our angle bisectors are meeting. So, since this is angle bisectors are meeting, this is going to be an end center. The point, the angle bisectors intersect. At. Okay, next one, find the value of EM if GM is equal to 5. And M, I guess that last part is deleted. GM is equal to 5. Find the length of EM. Well, we know that GM is equal to 5. That's all we need to know because this is an end center. Actually, I think we might need a little bit more information that's written away. So go ahead and erase this question. We don't need to work on it. With that said, that'll bring this video to a close. It was a little longer, but you can skip to any question that you wanted help on. Have a good day.